So today's lesson is on the compound interest formula. It's a short lesson where we're going to review how you use the compound interest formula. So the first thing we'll talk about is, of course, the compound interest formula, which is right on the screen for you to see. A equals P times 1 plus I to the power of N. Now, in the compound interest formula, A is your final amount, okay, of some type of investment where interest is compounded. P is your principal, or you can think of that as your starting amount, okay? 1 is just part of the formula. I is the interest rate, and N is time. Now, it's important to understand in compound interest, our interest rate needs to be per compounding period. So interest in a compound interest is compounded either daily or monthly or once a year or twice a year or 4 times a year or whatever it might be. And although the interest rate is always given per year, you need to adjust the interest rate to the proper compounding period. N is time, but N is really the number of compounding periods. So for example, if you had interest compounded monthly, you would need to take your interest rate and divide it by 12 so that you get a monthly interest rate. And then your N value would be the number of months that the investment collects interest. So if it were 2 years, then N would be 24. This will become clear as we do a few examples together. So let's do that next. So in the first example we're going to look at today, we've got Sarah purchases a $3,500 GIC that pays 4% compounded annually. So a GIC stands for Guaranteed Investment Certificate, and that's something that you would get from the bank if you had some money that you wanted to save. In this case, we have 4% interest, and it's compounded annually, which means you get interest once a year. They calculate interest once a year. So this is actually the simplest way to use the compound interest formula, is when your interest is compounded once a year. Because in this case, we have a principal of $3,500. Our interest rate is 4%, and we don't need to do anything with that number other than make 4% into a decimal. We don't have to divide by anything because it's a yearly interest rate and we're compounding once a year. So that's what we want. You get 4% every year, and you only get interest 3 times. So again, our N value is just 3. So now the calculation, 1.04 to the power of 3 times 3,500 is going to give us the answer. Now, as you do this, you can do all this on your calculator. You can basically type it in as you see it. But just be certain that this amount right here, okay, that you don't round that, okay, too much. We want to be accurate to the nearest cent. And if you do that, dealing in money, again, round to the nearest cent, that's $3,937.02. Let's try another example. So in this next example, we have Ethan has a savings account paying 2.3% compounded monthly, has a starting balance of $4,500. Okay, now since this is compounded monthly, the 2.3% interest, that's per year. So although you get interest every month, you don't get 2.3%. You only get 0.023 or 2.3%. You get a 12th of that, so we divide it by 12. And then we have to be careful because our N value will now be the number of months because you get interest every month. So for the first one, for 6 months, if I use this formula, the principal is $4,500. My interest rate is 0.023 divided by 12, and 6 months is half a year, but since we're compounding monthly, we can just realize that just has to be the number 6 right there. So you get interest 6 times. Each time it's a 12th of 2.3%. If you punch that in your calculator, you should get an answer. Now notice I put 0.023 divided by 12. I really don't want to round that number. Any rounding that you do here is going to kind of blow up when you take it to the power of 6. So in general, it's a good idea to try to do this all in one step. You can type it in as you see it, or you can kind of start on the inside and work your way out. It doesn't matter. So if I do it just by typing it in as I see it here, 4,500 times bracket 1 plus 0.023 divided by 12. And of course, my calculator will do order of operations here. Okay, when you do 1 plus 0.023 divided by 12, it does do the division first. Okay, and then finally my exponent button to the power of 6 should give me the answer, $51, and that actually rounds to $4,552 because that 99 cents rounds up to the nearest dollar there. So I'll just write that in. After 6 months, Ethan would have, what was it again, $4,552. Okay, next part just says, how about after 3 years? Well, everything's the same here. We're still going to start with $4,500, but now our time has just changed. We still take our interest and divide it by 12 for monthly interest rate, but now we have 3 years. 3 times 12 is 36. So n is equal to 36. There's 36 months in this example. And then again, we can pull up our calculator to get a final answer. 500 times bracket 1 plus 0.023 divided by 12, close the bracket, to the power of 36 gives me 4,821, and to the nearest cent, 14 cents. Now, technically in this example, we were asked for the interest earned. And when we're dealing with the compound interest formula, we always get the final amount with the interest included. So to calculate the interest for part A, which I didn't actually do, the interest that he earned will be the starting amount of the final amount of 4,552, subtract the starting amount of 4,500. And you can probably basically do that in your head and realize in 6 months he made $52 in interest. And then at the end of the, 3 years, the interest earned is now the final amount, which was higher than the starting amount, of course, subtract the $4,500. So the difference between the final amount and the starting amount must have been because of interest. So in this case, it's $321.14. Now notice that $52 for the first 6 months doesn't mean you get $52 every 6 months. The amount actually goes up as the interest compounds or builds upon itself. Last example in this short lesson, we have a 3-year GIC, and this time we actually have the final amount of the GIC, not the starting amount. So in this case, that's actually the principal that we're given. We're told the interest is 2.75% compounded quarterly. So as soon as I see compounded quarterly, I know that this 2.75% is always going to be divided by 4, because quarterly is 4 times a year. And in this case, it's for 3 years, but we get interest 4 times a year. So 3 times 4 is 12. We call them compounding periods. So whenever I work with the formula, I need the correct values of I and N there. There's 2 ways that I'll show you to solve this question. One is to fill in what you know. So start with 5,645.60. Just like that. Sorry, that's a decimal there. To the power of 12. And then we can actually solve for the principal. And to do that, to solve for the principal, we can divide by all this stuff right here. Since all this stuff times P gives us that, it must be that P is equal to 5,645.60. Oops, sorry. All divided by 1 plus 0.0275 over 4. Again, that's a decimal there, to the power of 12. You can do all that on your calculator. You just need to be really careful that you get it correctly. Now, actually, an easier way to type it in is to use a negative exponent instead of dividing. So we know that taking something, power 4, taking something to the power of -12 is the same as dividing. So I think most people actually find that an easier calculation to make than dividing, but it doesn't matter. You can do it either way. So I'm just going to hammer this into my calculator here and see what I get. So that was, let's see, 5,645.60 times bracket 1 plus 0.0275 divided by 4, close the bracket, to the power of, and then on this calculator I go 12 and then hit the negative sign. You might have to do the negative sign and then the 12, equals that's $5,200 exactly if you round to the nearest cent. Okay. So in this case, the principal, or the starting amount, was exactly $5,200. Now we did this question just by solving for the principal. However, I'd like to point out that we could, if we wanted to, have chosen to rearrange the formula first. And actually, if you can see, imagine I didn't plug in the final amount or the interest rate or n and just left those as variables. What would I get? Well, you would get that the principal is always equal to the final amount divided by 1 plus I to the power of n, or as we talked about, you could use a negative exponent. So that's just the compound interest formula rearranged so that you're solving for the principal. Now often in that case, we don't call it a principal, we often call it a present value. And that's a word that we use a lot when we talk about finance in this course, is the word present value. So we sometimes use PV instead. And then you might use FV for final value instead of that, instead of the A, but it doesn't really matter. So you could have, if instead to do this example, and if you did another one like it, you might just want to start with one of these two formulas here and just plug all your stuff in and get the 5,200 right away. Okay, thanks for tuning in.